Hello everyone, I am Dr. Praneeth. I'll be teaching chemistry today. Today we'll be learning the second part of the second chapter of the chemistry. Today we'll be focusing more on the Bohr's model and n number of models, its drawbacks and advantages, and what made it purpose to come live in this world and why it is necessary to read and learn about this model. Okay, so I'm excited to connect with you through Knowledge Temple, a platform dedicated to providing quality education and mentorship for students across India. Here, the main advantage of this platform is you will get a structured learning, live lectures, mock test, and performance-based rewards. So let's get started. So first, today's learning objective will be the electromagnetic wave. What is electromagnetic wave? The Planck quantum theory, photoelectric effect, and the atomic spectra. So now let's learn about the electromagnetic wave. So when we have in the past lecture we came across what is the Rutherford model, where telling about the Rutherford model in a very short, alpha particles was bombarded from radioactive substances on a gold foil, according which the posteriorly we had placed a deflection screen. Okay, so now there were drawbacks of the Rutherford model. The first drawback was the stability of the electron, which was not expressed by the model. Secondly, the atomic spectra was also not expressed. Thirdly, the distribution of the electrons. When he expressed his theory that there was a deflection in the direction of the alpha particles. Now he didn't explain why there is deflection. Secondly, he didn't explain is there any stability of the electron or not. He also didn't explain about the atomic spectra of it. Okay. Secondly, the drawbacks of the Rutherford model was, first, as we said, stability, because electrons are charged whereas planets are uncharged. According to the electromagnetic theory of Maxwell, charged particles, when accelerated, should emit electromagnetic radiation. The orbit will thus continue to shrink. The calculation showed that it should take an electron only 10 raised to power minus 8 to spiral into the nucleus. For example, to tell you in short, here he explained that the electrons are charged whereas the planets are uncharged. He said that suppose this is a planet, electron revolves, so electron is a charged particle and this particular region is uncharged. Okay, so he also said that charged particles when accelerated should emit electromagnetic radiation. He said that if electron is revolving around a particular orbit, it should emit electromagnetic waves. Thirdly, the orbit thus will shrink. He also said that when it is emitting an electromagnetic wave, he said that if it is emitting wave, there should be decrease in the charge. So when there will be decrease in the charge, the direction will come closer and closer. For example, it will revolve like this, in this manner. Okay, and it will shrink to a particular final stage like in the center. Now the drawback second was the atomic spectra. Atomic spectra was theoretical. He said that there is a continuous spectra. Like we can say these are the 7 colors we can see, which is known as Rydberg. But in real it was a line spectra. It was not a combination. Okay, so according to the electromagnetic theory, he said that accelerated electron is nothing but the continuously emits energy. The drawbacks of the Rutherford theory, third thing was the distribution of the electrons. He said that electrons are distributed along the orbits. The Rutherford model said that electron is around the orbit, but when modification of the Bohr came, he said that it is particularly on the orbital pathway, which is known as the orbital path, which is an imaginary lines. Okay. Thus, we can compare it with a live example of in our nature, that when sun emits an electromagnetic energy on earth, we can feel the heat. It is nothing but the electromagnetic radiation. Now talking about the nature of the electromagnetic radiation, the radiation of two types, the wave nature and the particle nature. Now talking about the wave nature, when we say it consists of an sinusoidal. Okay, so this is a positive, this is a negative, and this we can say it is a neutral. So they are like in the form of 3D. For example, this is going in x and y axis, so we have a certain z axis. Okay, so it goes like this. In this manner. Okay, now electromagnetic radiation was given by the James Maxwell. He said that when there is a propagation of the electromagnetic radiation, we can feel there is a presence of electromagnetic field and magnetic field. Both are present at 90 degrees. Okay, if this is an atom, this is going in this direction, so particularly we can see this is electric field, this is z-axis, this is y-axis, this is x-axis. So z-axis will give the magnetic field and this is the propagation. So here it will go in the propagation, this will be the electric field and this will be the magnetic field. So properties of the electromagnetic waves are: oscillating magnetic field is perpendicular to the electromagnetic field. Propagation of waves is perpendicular to the magnetic field and the electric field. And electromagnetic waves can travel in vacuum. Thirdly, the speed of light is 3 into 10 raised to power 10 raised to power 8. Okay, which is also known as c is equals to speed of light is equals to 3 into 10 raised to power 8 meter per second. Now let's talk about the properties of the electromagnetic wave. The four properties of the electromagnetic spectrum. Spectrum is nothing but the band of colors of different wavelength. Okay, so here we can see there are a number of wavelengths with different frequency. For example, gamma rays, X-rays, UV rays, invisible rays, microwaves, radio waves, and long range radio waves. Okay, so this particular in a particular certain frequency, there are certain waves which can be visible. The representation of the electromagnetic waves is in the form of wavelength, which is denoted as lambda. Frequency is in form of nu, and wave number is in form of mu frequency. Okay. So representation of electromagnetic waves in a lambda is basically their wavelength. The wavelength is basically distance of the two troughs, crest or trough. Okay. So we can see when there is a propagation of the waves. So this point is known as crest and this point is known as trough. So crest A to crest B, the distance can be given as lambda. Okay, so lambda is equals to A to B. The SI unit is meter. A presentation of the electromagnetic waves. The electromagnetic waves is frequency, that is number of waves in per second. For example, there is a propagation of the frequency from, for example, we can say 0 second to 1 second. This is 2 second, 1 second. So waves taking place in 1 second is nothing but the frequency. Now the relation between the speed, frequency and the wavelength. The speed is equals to c is equals to frequency into wavelength. So here we can say that c is equals to frequency into wavelength. So now the representation of the electromagnetic waves in the form of wave number. The wave number is the number of wavelength per unit length. Okay, so it is nothing but the 1 by lambda. So here we can say that wave number is inversely proportional to the wavelength. Okay, now let's solve a question and get this concept more clear. It says that calculate the wave number and frequency of the world radiation having a wavelength of wave. So here the given content is wavelength, which is 4000 angstrom. Okay, now we know Vc is equals to mu into lambda. So see, we know 3 into 10 raised to power 8. Frequency we don't know, and this we know as 4000. Okay, so this we can write as 3 into 10 raised to power 8 into mu is equals to is equals to V into 4 into 10 raised to power minus 7. So this comes as 3 divided by 4 comes as V. V will come as 7.5. Now, as we know, frequency we can write as wave number as 1 by lambda. So frequency is equals to wave number is equals to 1 by lambda. So here we know lambda. So lambda is equals to 1 by 4 into 10 raised to power 7 minus, which comes as 2.5. I want you to just pause this video and solve this question. Okay, so here they have given the wave. We have to find the wavelength frequency of the light whose period is 2. So period, that means time they have given. Time is equals to 2.0 into 10 raised to power minus 10. So time we know it is inversely proportional to the frequency. So frequency we know 1 by 2, which comes as 5 into 10 raised to power 9. So frequency we know, now we know C is equals to mu into lambda. So 3 is equals to frequency we found out, that is 5, into lambda we have to find out. The lambda is equals to 3 by 5, which comes as 6. So 6 into 10 raised to power minus 2 is the answer. So now let's learn about the Planck's quantum theory. So wave nature of the electromagnetic radiation is in the form of diffraction. Okay, so wave nature of electromagnetic radiation is also in the form of diffraction and the interference. Interference means if suppose there is an obstruction in the source of the light, so we can say there is a passage of the light which passes through the gaps of it. That is known as the interference. Okay, so wave nature of electromagnetic radiation is not obeyed by the black body radiation, photoelectric effect, line spectrum, and the variation of the heat body. Black body radiation basically, if in easier terms, it can be defined as in the black shirt. If we are wearing a black coat, then the radiation emitted by the black shirt is not comfortable in hot, because largest amount of hot radiation heat is absorbed by the black shirt. But in the case of the white shirt, we don't feel any warm because it doesn't absorb any radiation. Okay, so black body basically emits and absorbs all kinds of frequency uniformly. Black body is nothing but the carbon black. Now black body radiation, the intensity depends on directly proportional to the temperature and the wavelength. So for a graph it have given which is intensity versus wavelength. Here T2 and T1 they have given. T1, as we can see, is having a area shorter than that of T2. So here we can say that T2 area is greater than T1. So Planck's quantum theory, he said that energy is transformed from one place to another in the form of packets of energy. Okay, which is in the form of the continuous wave. Okay, so packet of energy is nothing but the quantum, and the energy is directly proportional to the frequency. So he said that energy is directly proportional to the frequency. So energy is equal to constant V, and this H is known as Planck's constant, and Planck's constant value is 6.6 into 10 raised to power minus 34 joule second. Okay. So let's solve this question and let this concept get more clearer. A 100-watt bulb emits a monochromatic light of 400 nanometer. Calculate the number of photons emitted per second. So here they have given the watt. What they have given, that is 100 watt joule per second. Okay. We have given monochromatic light of 100. That means lambda is given as 400. Okay. So lambda can be converted into 4 into 10 raised to the power minus 7 meters. Okay. So now we know the formula as the work done is equals to n into h, number of h into a.